was the last one? Okay, so next up is Nora. Have a little talk, and then we'll have some beers and some food, I don't know, coffee or whatever. And then we're going to talk about Terraform, and you're working currently at Uprise.
I currently work at Uprise and Electronic Arts game and so I'm just going to prove to you that I actually don't have anything. I actually bought /ignore.it a couple of years ago. I pay about 500 crowns for that every year. And the best thing I figured out to do with it is doing demos. So, good. No records. No instances. This is my presentation. So another Terraform, another HashiCorp tool, Terraform. I found it about a year ago, and I've been a big Puppet fan, so I like how it looks. And that's what it does. It has a bunch of providers. Well, first of me, I've already said it. If you've seen me before, it's probably because you came to our AWS Stockholm Meetup that I co-founded by tweeting out of the blue 2011, and no one said that we had a meetup group, so I started. And then there's more than just me now because I don't have time. I have a 2.5-year-old son at home as well. And I like Vim, as most of the other presenters. But I expressed it in a slightly. So, Terraform is a tool. It used to be a configuration language. It's not completely true anymore. This is from a presentation I did internally in April. So now it's actually HashiCorp configuration language. A product, you can actually buy something called Terraform Enterprise. I'll talk a bit about that later. And it's written in Go, as all of their tools except Vim. You have sort of these primitives that you use. There's resources, there's variables, and there's outputs. And you use these in combination. But you can also have like very, very high level things, like a DNS record, or a GitHub organization, or Heroku applications. And really low level stuff like the internet gateway in AWS, there's route tables, all that kind of stuff. It looks a bit like this. Is it actually visible from over there? I didn't know it was going to be a television, but I tried to blow it up a bit. I create a AWS instance called demo, but I want 3 of them. And I actually name them after the index of the count. So we have demo 1, 2, 3, or actually 0, 1, 2. Yeah, I could have added a +1 there somewhere. And just to get the idea of how many providers there are, these are not everything. These are the ones that I could get into a slide. That wasn't only AWS. So Atlas is their enterprise UI around console, all other HashiCorp stuff. AWS Chef, CloudFlare Console, DNSimple, I'm going to use that one later. And a bunch of others. CDNs, Google Cloud, monitoring, little Librato. The best thing about being the last is that everyone loves you when you finish. What's interesting now is that you can actually combine a set of resources into a module, and then you can, it's still kind of hard, but you can then use the same module to implement the same type of infrastructure multiple times. So you could actually do something like having there's going to be code examples later. Having a VPC module that actually sets up the same amount of subnetworks that you have availability zones in the region that you're in, and you have private and public networks. You map the IPs on launch on one network but not others, and then you can reuse the code and do this multiple times for different environments that you set up. And yeah, there's going to be code later. Let's see if it works. It did work when I left work. And the interesting thing is that you could actually layer this. So you could have like low-level things like VPC, network, NAT gateways, whatever. And then you could have like a high-level thing like our application, and then say like it's called this, and it needs 3 networks. And then you have your SQS queues, your SMS topics, your RDS databases, and it's all configured lower down in the next module below. It generally looks a bit like this. There's an awesome module. You have a main Terraform file where you actually create all the resources. You output things, because if you want to use something from another module, you actually have to have a module that outputs something. So you can actually reference resources between modules and between resources themselves. And this is between providers as well. And that's why I'm using DNSimple later, because I want to show you that I can actually create a resource that references from DNSimple reference an AWS resource. You have your variables, and that's essentially inputs. So you get a block, start a block, module, bump, then you have the inputs that you variables, it's the inputs to the module that you need to set, and then you get some outputs that you can use for the next step. And then when you get a bit bigger, I haven't done this myself, I want to. You probably have something like this as a structure. Terraform root, you have providers, there's AWS, then you have production environment in US East, and you have production environment in EU West. And in there, again, you instantiate all the modules that you want to use for every environment or every region, and then you supply it with a variables files. That's not a variables.tf. It's much more fun with the demos. And then probably you have some high-level modules in the same repo. This is sort of a basic structure. And then all the low-level ones are, you would probably want to have them in a separate repo to version them, and actually you can actually then essentially choose a tag in a git checkout. So if you reference a module that's on GitHub, you can say I want this tag of the module for production and the later one for staging to check if it works. There's some tiny problems that comes up. I just saw the loop or the count before, but there's no loops. So for some resources, this count parameter you can throw in to emulate sort of a loop. There's no conditionals, so you can't say if I'm on EU West, then I want this, but if I'm on EU US East, I want that, or staging. And this was a thing that was in before, but it's not true anymore. Before, you actually had to stringify all data you passed around and then split them up again if the input that the module expected or the resources expected actually was a list or a map. Then you had to stringify a variable and then cut it up again with split or something. This goes quick. Okay, so we're going to set up a VPC with some networks. There's going to be an ELB. There's going to be a bunch of EC2 instances that I made this afternoon with Nginx on them, and there was supposed to be a data load thing included, but we're releasing a game in 2 weeks, so I've been a bit stressed. So sorry about that. A DNS record from DN Simple. Oh, sorry. Yeah, I'm supposed to switch this. Is it okay or is it crap?
It's too small.
So, first, if we use variables somewhere, we need to declare them. The resolution is a bit different from my laptop, so you can't see this top one, but it says VPC CIDR. So it's the VPC network CIDR that we want to use. What region are we in? What's the AWS profile I'm using? ACs, I'm actually not going to use this one now. Subnets, public subnets and privates, and the last one you can ignore. I did some last minute changes. And we will also, if you want to, we can also look at the actual VPC module. I started doing this myself, and then I realized the VPC module is actually one that's really, really good, and you should use it if you want to try out Terraform on the side. But most of the other ones are not really applicable for most people because they're very, very specific to the environment that the person that developed it did develop it in. So here you can see that I reference some variables. I want to use the variable VPC CIDR here for the CIDR. I want to use the subnets. And here you see the reference. Okay, I'm just going to do. I'm sorry, this is really, really small. I think it's small. So here you see something that I mentioned earlier. The VPC module has an output that is public subnets as a list. So I use this when I want to create the ELB and say that all the subnets that I define in the module for VPC should be used for the ELB. Instances we can sort of ignore. There's a security group for the ELB, which also because of time constraints allows everything, so it's not really interesting. There's a listener. If you set up an ELB before, you know how this, what this is. Blah 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 blah. So,
is it a classic ELB or a new application?
it's not an application load balancer. I tried it out. I didn't know I had a 2-day event yesterday in the day. We have journalists in the office, so I've been. It's been crunching time for me. So it's a classic ELB. There's also a ALB if you want to use that one, already available from Terraform. Security group for the ELB. And here's the actual instance that I want to use. And I want as many as I have availability zones now. You probably want more in the usual case, but you could probably use something like availability zones times 10, and then you get 30 or 20 if you have 2 availability zones. I prepped an AMI. It's going to be tiny because, just as Rick did, I use my personal account for this, and I'm a bit cheaper than he is. And I'm also going to make sure that every instance I create is in a separate subnet. I have 3 subnets because there's 3 ACs in EU West. I'm going to put one instance in A, B, and C. And that's what that does. And then subtags, security group. And then I have some outputs. I want to know the IP addresses of my instances. I want to know what the load balancer is called when it's done. And I also want to do this. And now you can see my token. Hopefully going to revoke it. It's annoying. So here's the integration that I'm talking about. I have a resource that is a DNS record from a different provider, a different service, and I reference the value I set that it should use is the DNS name of the ELB that I create during this run. And then we put out the full host name that I create, the CNAME that I create on the system as well. It's enough. And my bin is in French and I haven't figured out why. That's what happens when you upgrade to Sierra too quick. No, it's in German as well. This is great. Then it can actually. Everything was crystal clear. You don't even have to ask me afterwards. I can see some of it. Oh, sorry. I'm just gonna. So there's generally 2 steps when you apply the change. First, you do a plan to see what's going to change. Terraform uses a state file that's essentially a version JSON blob that represents how Terraform thinks your infrastructure looks. And then it compares that state to what AWS actually gives you back. And if it's different, then it does some changes. That also means that the test developers, if you go in and change something manually, you can actually invert that. That's always the plan for me. And this is going to be too much. It looks a bit like this. It's a bit annoying.
But interesting things are at the bottom, isn't it?
Sorry?
Interesting things for us, isn't it, at the bottom?
It is as well.
Yeah.
But one thing that's interesting to see is that it says a plus, and there's 3 different things that can happen. There's a add, there's a change, or there's a remove. And the plus means there's a add. So we're actually creating something on AWS and DNC. And you can see the plus, so that's why I did that. So there's 24 things to add, 0 things to change, and 0 things to destroy. And then it needs to start to minimize tiny T2 micros or something like that. So what caught my attention with this kind of tool was that I before I left to work at EA, I did consulting for a couple of years. And one thing I did was move a startup's video streaming platform from their own hardware to AWS. One of the things that they had a problem with was that they had very limited storage, and S3 is a bit more convenient when you just want to push up more videos. Oh, faster than a button. So I could actually implement both staging and production environments with the same Terraform files by just switching out the variables. So you point out the different variables files or Terraform TF-Wars files. You can actually do identical setups with two environments and exact same code. And as long as you know what environment you're targeting, which is sort of where the tooling comes in, that's not really there, you can actually use the exact same block of code. Just, I want to target staging, iterate on staging until you think it works as you expect, and then you switch targets to production, and then you do the changes on production, and then you separate the state files to two different ones. Pretty clear again. So, so I created a CNAME called Justignore that points to my ELB, and I would love to do it. Have time to do something more interesting than just welcome to MDNX, but there it is, and two machines are not up. It works the first time. And sadly, I didn't actually do the proper way of actually shielding you from them, shielding each machine from the outside network, so you can actually access every machine separately. But what's interesting now is then the network falls. Ta-da! 3 instances here. There's a load balancer up and running. Oh, I missed the important part. BUS A, B, C. Load balancer spanning the 3 availability zones. And there's the CNAME for the ELB in DNC. Except that line. And the best thing about this is that you can give it to someone, and if they fuck up, you can just destroy everything. So that was a really eye-opener for me when I did it. Like, it was a very greenfield kind of thing, because they had everything over there, and they wanted it over here in AWS, and I could just sit and iterate. I was learning as I was going. I'm still crafty, as you can see. So I was just bringing things up, taking them down, bringing things up, and I did multiple times a day. It's not cheap, but they have some money at least. And this startup actually paid me that as well. So, as you can imagine, it's easier if you don't have anything in AWS right now and want to move there and start using it. Fairly recent, you can actually import things from a provider. So you can actually say import my load balancer. But the only thing it does is actually writing down the state. Then you actually have to write the Terraform code that represents that state, matches it, and then you have to do a plan, and then apply and hope that it doesn't destroy anything. And for some resources in AWS, you actually can't change them in flight. You actually have to destroy them and recreate them. But from the Terraform perspective, it doesn't allow you to you can't destroy for example, a S3 bucket that has data in it. And you can manage data in an S3 bucket with Terraform, but then you have to actually explicitly remove every piece of data as well before you actually remove the S3 bucket. So it won't delete anything that actually holds something that you want. It won't just delete the S3 bucket. And there's some other things. I think if you want to create a new auto-scaling group that's bigger, you can always size up an auto-scaling group. But if you want to recreate an auto-scaling group, you can actually tag it up with a lifecycle block that says create something before you destroy it. So you create the new resources, and then when they're up and running, you destroy those. There's some problems you didn't properly show you. So what you see here now is that we have a TF state file that it created. And that's the state that it uses to figure out what to do. But this is on my laptop. So one of the value-added things that HashiCorp does is it actually has a tool that runs Terraform for you and locks states when someone's running, and you pay for that. It's not that expensive, and I tried it out because I did a workshop with it. But maybe you don't want to, or maybe you can't, or maybe you don't want to rely on a startup with brilliant minds working there. But they're not. They understand this as well. So they have, as I said, an Atlas and Terraform Enterprise where you can actually, like a remote build service for Terraform. So you set up your things there, and they store state and run the plans for you. You can also just put everything in an S3 bucket and then fetch state when you try to run. Before you run. So if someone's working on it, they fetch state, they run, then you push the state back up to S3. And you can also include encryption if you want to. And I found a couple of months ago a tool called TerraGrunt from a company called Gruntworks. And what it does, it uses DynamoDB to set up a lock. So you store state in S3, and you lock the state in Dynamo when you're running. And when it's finished, it unlocks it. So you get remote locking that you actually have to share, and then you need a small configuration to actually tell them where the lock file or the lock database that you want to use. So that's what I'm looking at now. Quick, easy, crystal clear. Yeah, this is me. The code is up on GitHub. I can send out a link to a PDF or something if you want to look at my wonderful presentation. I'm on Twitter, blah, 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 blah. Do you have any questions? Everyone's, yes.
Is there any limitations of what you can do compared in Terraform compared with CloudFormation? Since Terraform is spanning multiple providers, does it cover all the stuff that you can do in Amazon, or are there limitations on the services or how you provision them?
There's, I haven't used, I'm a complete newbie in AWS. I'm just here because I get free beer.
I would
So
say
my-
they
my
are a bit
two
slower.
favorite things.
Slower than CloudFormation.
So for new things, they are a bit lagging. But for hybrid environments, they are awesome. And with lagging, I mean, they are a couple of weeks or maybe sometimes months behind, but not much. For most things, they are up to par. And if you have a hybrid environment, they are like awesome. Which CloudFormation is it?
No.
Of course.
So, and one of the use cases for us is that we have both developers and operations working on infrastructure right now, because that's what we traditionally did. They didn't have operations at Uprise 3 years ago. They hired the first dedicated operations engineer there. And one of the problems that we have is that everyone does sort of their own way. We have some homegrown tools that we use internally, and we also integrate. We use Akamai extensively for CDN and site shield and all the sort of protection stuff and security stuff, because we want to cache as much as possible, as close to a player as possible, but all of our data is done. And what we do is we've written a Python script that fetches all the sitters or all the IP addresses and networks that Akamai uses that we need to whitelist on our ESS. And then we generate a Terraform JSON file that's, you can actually write pure JSON, and that's Terraform valid. And then we can use that as input to a security loop. So that's one of the use cases. I guess you could do something similar in CloudFormation. Can you actually get a CloudFormation template out into an editor and just put data in it? I mean, a topper like that.
Or it's just a JSON or YAML file. So, but if you want to, when you start with it's harder because it's object data.
Yeah.
So it's not code per se, it's a description.
I mean, there's a big benefit, and it's the benefits where you can see what happens. That's a bit obscure transformation.
You have changed that
Upload
CloudFormation.
your stack and see what happens.
I would say, look, if you have to use one tool, you should use Terraform.
I think if you wanna avoid the CloudFormation JSON stuff, I think Ansible would look like much better than this. I don't know.
Yes, but then you only have the EC2, like the AWS.
Yeah, of course. I mean,
So-
we are talking about AWS, not
Yeah, I know.
not about.
And also Ansible doesn't really handle order. Terraform calculates the correct dependency order of stuff.
But when you write the playbook, it's order.
Yeah.
Yes, but you have to order.
Yeah, of course.
And it's sequential, so it's super slow if you do a lot. I mean, if you like us try to manage every resource we have, that would be terrible. So, but Terraform is really quick.
You mentioned that like conditionals aren't supported, so I'm just curious, like if you would have sort of like you described, you would describe your you would have different var files, right, for like a staging and for production.
Yeah.
So just let's say that you would have like one thing that differs. Let's say you would have a database in production, but you wouldn't have it in. I'm not. Would that be doable? Would that be super hard to? Is that like? How would you do it?
You like if you there are provisioners for databases and stuff. And depending on how you do it, like I only use it for provisioning machines, and then using Kubernetes to manage containers. So maybe you are more versed, but otherwise you would have to omit that step, like in your code.
Okay, so would you have to duplicate your modules?
What you can actually do is when you run something, it actually takes every TF file in a directory in just one step. So what you probably would do is you would separate out the database step into a separate file and have that in production, but not in staging. So you have like one file with the production database, and you can also, because it just concatenates all the files into one big file, then does the planning, and then does the execution. So if you have one step that you want to exclude from a specific environment, you extract that into a separate file, and then you put in variables from the Terraform TFRs files, but you just don't use them in staging. So you could even have the same thing.
Okay, so I would have to concatenate the files myself?
No, that's how it does it.
Okay.
So if you run Terraform and say EU West 1 production as a directory, and you have 4 TF files in there, it takes all these files and concatenates them, builds a build plan. You can actually see all the relationships. It does the puppet thing, essentially. So it actually figures out in what order it has to create things so the relationships actually work. So for some things, you have to have a launch configuration before you have an autoscale. So even if the autoscale group is the very first thing in the whole file, it actually figures out that it has the launch configuration first.
Okay, so but if it, let me know if you'd like me to take this afterwards. But if it picks up all the files in the directory, there must be a way for me to exclude one file.
No, you don't have, like, if you have two branches, you have your your stage branch and your production branch. And your stage branch, you don't have the database file.
I see. Okay. So I would sort of have to have duplicates of some files.
Yeah, that's
Or
a very
duplicates in terms of, but you probably have projects.
Yeah.
If you have some reasonable versioning system.
That would be messy to make sure that every branch is up to date, right? So it's a bit tricky. But
it's also, I call me a bit strange and conservative, but I do think that if you do this at a scale, you probably have a releasing strategy which includes tags and branches. So what you do is you actually have a branch for staging that goes into production, or maybe into master, or that you tag that before you run. When you have a successful run, you tag that and say this was version 1 of my infrastructure, and then you can fall back on that. So you can actually, like, okay, I want to do my dev environment on tag 1. Okay, in with variables from dev, and run the tag for version 1 with the code, and then probably you have to fix them later. So at least, I don't know how much operations you've done. You have done a lot, I can see, or you like it too much, which I can see by the beard. But it moves a bit slower, and my reasoning for using something like this is more about you get a diff of what changes in Git, because everyone uses Git. And you can actually see who did the changes. I guess there's a very good audit trail in AWS as well, but extremely good. It must be with all these IAM profiles that you have to create. And then in the end, we all just give everyone the same temp file and just say, here's administrator X. So my point, for me, it's more about seeing how things change over time. That's easy to digest for me when I'm working, because AWS has been doing this on and off since spring. AWS is the monstrosity most of the time, really confusing, and there's too much click to click. So I like it. But, you know,
you carry on.
I'm just rambling.
In terms of the state file, is that the kind of the truth of what Terraform sees as what's been provisioned? Or does it go out and check if you have like a named instance that you would like to create? Does it go out and check if that's actually there before executing that.
It will talk to the APIs, yes.
Yeah, or, and verify that it's there.
Yes.
Yeah, for some resources it has to, but it tries to be smart about it, so it assumes some things. And I also think that you have two files. You have the Terraform state, and then you have the backup file. So if you do a plan, you could actually, I think you can dip that between the backup and the change. So we can actually figure out that, okay, these things are supposed to be changed. I will check them with AWS, but not everything that I use. So it figures out the dip on what changes, and then checks if that's actually true for those resources that you wanted to change before running.
The plan, or just before running.
Before running, so the plan
So
files
the plan
are
can differ from active or something. Plan, even if I haven't changed anything, it doesn't become clear.
yeah. So the plan it could have changed in 07. That's the one thing, right? Before you actually, the plan file was just a JSON file. Now it's a binary file that looks a bit different. So I'm not sure what it did.
No, I don't know.
Okay.
I'm agreeing to not knowing.
Sorry, did you say it's a state file?
No, if you run a plan and then you run without outputting the plan and then run an apply, Terraform doesn't guarantee that the plan you saw is exactly what it's doing. So what you can do is output a plan file and it will do exactly what you did in the plan step. And that changed. They did, I think what they did is before, when they did the plan, they actually fetched all the resources and did it. And now they only fetch what changed instead. So things can change from the AWS side because someone removed that database that you really need. And that won't happen now. But previously it would have happened, but you wouldn't have known about it.
Thanks.
It's great. It's fun. We all love operations, right?